Jim Kunkel here. Make sure that you subscribe to my channel and set the notification bell to all so that you won't miss any of my new content. This is a continuing discussion, and this episode of Global Topic will be focused on the NSF 600 health regulation. In this episode, we're going to be talking about coating systems and project considerations. Joining me again is Corey Brown and Mark Thomas from Tnemec. Welcome, guys.
Thanks, Jim.
Hi, Jim. Thanks.
Hey, the first conversation we had was very interesting, and I've got a lot of great feedback from individuals who have watched the episode. What I wanted to do, in talking about the previous episode regarding the NSF 600 health regulation, we covered the history and, in a brief overview of what's coming starting January 1st, 2023. So for the engineers and the specification firms that are out there, and they're looking at, beginning to be ready for this regulation, what coating systems would be compliant?
Well, Jim, just a quick recap for everyone that the standard 61, as it applies to potable water coatings, is not going away, but they've added in that the NSF 600 that is greatly reducing some of the common solvents that are used in industrial high-performance coatings. And so what you're going to see is a move towards very high solids, if not 100% solids products. So that really eliminates the potential extraction of these solvents and chemicals that NSF 600 is now starting to control. So you'll see things like 100% solids epoxies, 100% solids aromatic polyurethanes that have been on the market for quite a few years. So it might be new to some of the engineers out there, but those have been proven technologies that Tnemec, among other manufacturers, have sold for 10, 15, 20 years. So those products are out there. Of note, we'll also be able to maintain, at least for Tnemec, our HydroZinc, zinc-rich urethanes as the primers for an interior of a water tank or even a pipe. So zincs are sticking around, and you'll see a movement towards 100% solids. On the Tnemec side, those would be things like our Series 22 and FC22 epoxies and 406 aromatic urethane.
So that we now know what coating systems are compliant, what considerations are important when it comes to the specification of proper surface preparation, prior to the coatings and lining application?
I could probably take a stab at that one, Jim. Really, I probably should address that question from a means of anchor profile. Because in my mind, that's probably the biggest change that we're facing that specifiers need to be aware of. So coating adhesion relies on a couple of different things. It relies on mechanical adhesion, which is that anchor profile that we kind of think of as the tooth that the coating can hold on to. But we can't forget that there's also, a molecular bond that happens between coatings and steel surfaces. And that's always been, one of the reasons why we call for profile on steel, is because it increases the surface area of the steel, and therefore it increases the number of bond sites that coating has to form that molecular adhesion. So Mark's talking about some of the changes in some of the coatings moving towards higher solids. The properties of high solids coatings, of course, is because they don't have solvent in them, they're a little more viscous. And that higher viscosity sort of predetermines the coating's ability to make more intimate contact with the steel. It doesn't wet the steel out as well as old low solids coatings did. And so it's not a big deal. We just have to increase the height of our anchor profile to make sure that we've increased surface area even more and provide a better tooth and more surface area for those molecular bonds to occur with high solids coatings. So what you'll see on our data sheets for products that Mark talked about, like our Series 22 and FC22, is a 3.0 mil anchor profile requirement. That's almost twice what we've issued in the past. There's some SSPC standards out there that only call for a mil of anchor profile. A lot of our old epoxy linings called for 1.5 mil anchor profile, but we're going to increase that now up to 3 mil profile. And so specifiers will need to know to make note of that in their specifications and make that a requirement.
And Corey, just to clarify too, that would be for direct application with those high solids materials. It does require that higher anchor profile. If you're using a zinc primer, that's generally going to be a lower anchor profile, but they'll just want to check those data sheets for the particular products, and depending if they're going direct with an epoxy or an aromatic urethane or going direct with the zinc first. And
yeah, very good
as it relates to specifications too, Jim, I wanted to add, as engineers are moving towards some of these products that, again, have been out in the market for several years but might be unfamiliar to them, there's really 2 bits of advice that we're providing to those engineers as they're evaluating these products, these unfamiliar products. And that is, definitely ask your coatings manufacturer for case histories with the same type of system and the same type of environment. I think that provides assurance that these are proven technologies. They've been out there for a length of time, at least long enough that there can be a high degree of assurance that it's going to perform properly. The other thing that we always advocate for is a review of performance data, especially with new products that are new to the market. You will be seeing some manufacturers introduce new products that are meeting NSF 600. And a great way to compare what you're familiar with what you're unfamiliar with is through performance data. And I was going to call out a few tests that we feel are really important to engineers. One is a basic immersion test. It's ASTM D870. It's a straight immersion test. We conduct this on all of our immersion grade products, and we run it with tap water. Our requirement is generally about 2 years in tap water with no type of adverse effects, or with deionized water, which obviously is a much more aggressive, smaller molecule that can get forced through the film. We usually run that for about 2,000 hours. You also want to look at a humidity test called ASTM 4585. That would be applicable to a coating that's above the water line in a water tank, say, but in extremely humid conditions. Tnemec generally runs those tests out to about 2,000 hours as a minimum. And then there's 2 corrosion tests that we feel are really good indicators of overall coating performance and durability. And that would be B117, which is a salt fog test that a lot of engineers are familiar with. That's been out there for a long time. There's a huge depth of data with older technologies that you compare apples and apples with newer technologies. And then also D5894, which is a cyclic salt fog UV, which is extremely aggressive. You're seeing that being offered by manufacturers more and more. And that is also a relevant test. So just a handful of tests that I would really key in on if you're an engineer. Your coating supplier can do side-by-sides with what you're familiar with, what you're considering, so that you can see how those performance metrics measure up.
For the project, quality control and quality assurance, what testing or inspection methodologies should be specified and related to the NSF 600 related coating projects?
Okay, well, we can talk about quality control on two different wavelengths, Jim. We can talk about manufacturing quality control. Here at Tnemec, we are governed and monitored by NSF for all formulations that we have certified through them. We have very tight manufacturing tolerances to use all what they refer to as virgin materials, so unopened containers of resin, pigment, additives, anything that we're putting into the formula has to be new, fresh material. We cannot deviate from our established formula on any one item more than some certain percentage that we might have to use to adjust the batch at the end of manufacturing. And then we have to stay within all of our established quality control criteria. So we check, a multitude of physical characteristics on the coatings, including things like viscosity. Weight per gallon is a good measure to take during manufacturing to know that something's been put together the right way. Resistance to sag is something else that we check to make sure that we're producing quality products. We keep all of that information recorded internally on our documents, our manufacturing documents, and then NSF comes and they audit our manufacturing locations on an annual basis, unannounced audits. They just show up and they'll want to see that we're manufacturing according to the way we were certified. Then we can change wavelengths and talk about field quality control, which is usually, as you know, performed by third-party inspectors on job sites. I don't think we're going to see many changes to what occurs because of NSF 600. I can tell you, it's always, in these certifications, it's kind of always been about coating thickness. In the previous episode, we sort of described that surface area to volume calculation that NSF uses whenever they're trying to determine a minimum tank size or a minimum pipe diameter size for a coating certification. And these standard test methods are always written to try to exclude as many variables as possible and make the test as repeatable and reliable as possible. Well, coating thickness is one of those variables that they try to keep a really tight rein on. So we are certified with our coatings to a certain thickness, and if field applicators exceed that thickness, then there's some conversations that have to occur about whether that lining is still compliant or not. So as far as field inspection goes and specification writers, I think it's critical to specification writers that you include SSPC's PA2 as part of the field quality control assurance. That's an old standard method that SSPC developed for determining the average thickness of a field applied coating. It is incredibly useful in these situations because it takes square footage into account. And if we're in a situation where a field applicator, as they sometimes do, exceed the specified thickness by a few mils, we can calculate the square footage that's affected. We know the volume of the tank, and then we can determine if we're still within the certified range based on that surface area to volume calculation. So PA2 is the standard that helps us bridge that gap. It's critical for specifiers to include that in their specifications.
Very interesting. Mark and Corey, we've had a really great, conversation related to coating systems and really project considerations for engineers and specification writers. Is there anything that we did not cover during our discussion here that you would want to leave with the viewers?
Well, Jim, just one thing, just a friendly reminder that this NSF 600 has already been adopted, and it's scheduled to take effect January 1st, 2023. And just the reminder that when you're specifying to the NSF 600, make sure you include in your specification must be certified and compliant to NSF 61/600. And that way you're ensured that any of the coatings that are in your specification or being applied on that project are compliant to that new NSF 600.
That's very important, very important. Corey, Mark, thank you very much for the opportunity to have an additional discussion. And I do believe we're going to have an additional discussion here, the final discussion related to contractors and having them related to their readiness and everything for this upcoming health regulation. Thank you very much.
All right. Thanks, Jim.
You're welcome,
have a great,
Jim. Thank you.
Yeah, have a great day.
You too.
You too.